Hey there! Turn on your speakers. Do you have finals week coming up? Projects due? Homeworks are piling up? Are you freaking out that you're getting boxed in with deadlines? Here's an idea. Get help. Think Geek Exams. Find us on Facebook, Twitter, or YouTube.
So welcome back. This is the 9th homework, and we have basically a bar with uniform force on the left side, and then the force density decreases as we go along the x-axis over here. And so we're told to find the resultant force R caused by this, and also the location where the resultant force is acting, if we were to think of it as one force instead of this uniform force. So we have to make use of calculus for this. So first things first. So there are two parts to this. The first part, the force is uniform over here from 0 to 2. So we're going to basically find the force R from this. Force R, 0 to 2 is going to be 0 to 2, if you can see me writing on the clipboard. And every meter that it goes to the right, there's 462 newtons that are added. So basically this is the formula for the force for the first 2 meters. The second part is 2 to 6 position. This one we're going to have a force equation which is going to look like minus 462 divided by 4. That's the gradient. I'm going to calculate that out. 462 divided by 4 is 115.5, so it's going to be minus 115.5 x. So as we go along this x-axis, it's going to diminish with time, so that's why we have a minus sign. And then there's going to be intercept. The y-intercept for this, it's going to be 3 by 2, 462, and that is 3 by 2 times 462 is 693. So we can write this as 693. So that is our force equation for this part. It's going to be minus 115.5 x plus 693 dx, and that's our total force. And we have to calculate that out. So right off the bat, it's 462 x 20 plus minus 115.5 x squared over 2 plus 693 x, going from 6 to 2. So the first part is 462 times 2 is 924, so it's 924. And the next part is 6 squared divided by 2 times 115.5, negative 115.5 plus 693 times 6, and this is only the first part. The next part is minus minus 115.5, I'm sorry, I'm coughing, times 2 squared divided by 2 plus 693 times 2. And that should give me 924. Okay, 924. Yeah, that is correct, because we are getting half on this side and half on that side. So 924 times 2 is 1848. Okay, that's our total amount of force. So I'm just going to write that in here. 1848 on the answer sheet, and then we have to calculate the MR to get the X bar over there. So MR is pretty similar, except we are going to multiply each force by X at the point where it's acting, and it's 115.5 x squared plus 693x dx. So integrating, it's 462x squared over 2, going from 0 to 2, and minus 115.5 x cubed over 3 and 693x squared over 2, and we have to find the answers for all three of them. So the first one's easy. It's 0 is 0 over here, so we just need to do the 2 part. 2 squared over 2 is 2, so 462 times 2, so 462 times 2 plus. Now the next one's tricky. So there is the positive part and then the negative part. So the positive part is minus 115.5, and we got that same thing on the other side, so I'm just going to type that in here, times 6 cubed divided by 3, and we have the same thing on that side. It's 2 cubed divided by 3, and that took care of the middle portion. The last part is we have again positive and the negative part. Positive part is 693 times 6 squared over 2. So we're just going to copy that, and we're going to write 2 squared over 2, and that's your final answer for the MR. So this is 4004. So X bar is going to be 1848 divided by 4004. That doesn't look well. Actually, it's the other way around. It's going to be 4004 divided by 1848, and that is 4004 divided by 1848, and that is 2.1667, and the answer is 2.1667, and grade this, and both are correct. Thank you.
Think Geek Exams. Our agents have Masters of Engineering degrees from MIT, Stanford, Georgia Tech, Caltech. We give you solutions to mathematics, physics, computing, and engineering. Find us on Facebook, Twitter, or YouTube.